Good evening, everyone. Please wait for 2 more minutes. Let's others to join. Thank you. Okay, let me start the session. Good evening, Honorable present here. Thank you for joining. Those who joined new today, I just give a brief introduction about me. This is Saravanan, PhD scholar and Prime Minister Research Fellow of NIT Trichy, Department of Civil Engineering. I am a PMRF scholar. So, as a part of PMRF deliverable, I have to take at least 4 hours of class in a month in nearby colleges or a polytechnic school, or I can take NPTEL classes. So as a part of PMRF deliverable, I am taking this course Air Pollution and Control for this semester. I have already taken 2 more NPTEL courses in problem solving session for integrated solid waste management and plastic waste management. And this semester it is air pollution and control. So we are in the 11th week of this problem solving session. So first 10 weeks we have discussed about the basics of air pollution and the air pollutants and their sources and its impact and its effect. I mean, how it's getting dispersed based on the meteorological parameters, the dispersion phenomena, and then lapse rate and their stability conditions, and then how to measure this pollutants by emission inventories, and then different sectors of air pollutions like transportation, um, like industries, agricultural, residential, and commercial area. That's what we are going to see in this 11th week also, how to prevent or mitigate these pollutions in the same sectors, four sectors. Okay, and then we are also 1 week we have discussed specifically on application of remote sensing on air pollution control or monitoring, and then 1 week we have specially dedicated for indoor air pollutants. As we all know, there are how much we have discussed how much impact of indoor air pollutant on the human health and how to prevent that. And 8th week, we have discussed the global and regional environmental issues like acid rain, global warming, greenhouse gas emission, and then ozone layer depletion and all. And 9th week, we have discussed the air pollution control devices for particulate matter as well as for volatile organic compounds. For particulate matter, we have discussed gravity settlers, cyclone separators, fabric filters, wet scrubbers, and electrostatic precipitators. And for volatile organic compounds like same particulate matter itself, absorption, and condensation we had seen, right? And oxidation is also another one parameter. So, and 10th week is that is the last week we have discussed about the air pollution emission standards, national and international policies, acts, rules, and regulation. So how India is having this type of acts like national ambient air quality standards, that and all we have discussed. Also some of the problems related to the air pollution control devices like what we have discussed, like gravity settlers problems and electrostatic problems and all. I have also shared the problem formula sheet in the Google Drive, that also you can look into. And last week we have stuck with one of the problem for fabric filters. In that, I think the question is wrong related to diameter. It was given as width. That's why we have struggled with the width into length calculation. But it is, you have to take that as a dia for the filter bag, and you have to calculate the number of bags by dividing with the total area. Got it? So that's the last week we have stuck that. And then this week, 11th week session, we are going to discuss about the emerging technologies and strategies to mitigate air pollution, current challenges, and way forward. That's what we are going to discuss. Okay, let me go with the lecture material. So our session will be for 2 hours. So first 1 hour will be the same lecture material what sir has taught in the YouTube videos, and next 1 hour will be the old assignment problems solved. Okay, yeah. And don't forget to give the assignment by end of every Wednesday. And next week will be our last class, that is the 12th week. And I have also scheduled a special class on next Wednesday. Next Tuesday will be our regular class, last regular class. And Wednesday I was given a scheduled a special class to discuss this 12 weeks assignments. Okay, what we have given in the SWAYAM portal for revision of as a revision for our examination. Okay, yeah, hope you all are aware of that. And if you are going to get the certificate, please give your assignments on time. Yeah, and best of 8 will be taken for more consideration. Yes. Thank you. So for this 51 lecture, 11th week, we are going to discuss about the uh, emerging technologies and strategies, also the international environmental treaties. So we have a lot of global treaties or conventions or meetings happened to discuss about this global problem, because air pollution is not only a national problem. If I am emitting pollution from my industry in India or in a single state, that will not, that I should not think it will not affecting my problem, my area alone. It is a global problem. It may reach anywhere, but it will dispose, and it will be assignment 4, question number 5. Yeah, can we discuss this in the next week? Because next week extra session we can discuss this, ma'am. Wrong, but we'll get mark right, but we not get the marks out of 190. Okay, that and all I will specially write to NPTEL team. We will discuss what are the wrong questions in the next week extra session, and that and all I will write to NPTEL team to correct the marks. Yeah, for that only I have scheduled the special class, ma'am. We will discuss on that day. Okay. Okay. Let me start with this lecture. So that I should not think whatever the emission it is happening locally, that has a big impact on the global level. Whatever the industry that sulfur I am emitting, that may create acid rain in somewhere in American region. Whatever the ozone depleting substances I am emitting in India, that may create ozone hole in Australian or Antarctican poles regions and all polar regions. So that's why all the countries have come up for this type of meetings, and they are signing different treaties, and they are having agreements to mitigate this type of impacts, how to reduce the effects, or how to reduce the future, how to prevent the future from this type of impacts. That and all they have discussed, and they come up with lots of treaties, and they have a target also. In 2030 what we have to get, in 2050 what is our aim. So that and all they have fixed, and all the countries are working on that, and they have given different allocation to developed and developing countries, how much developed countries should pay or contribute, what they have already emitted to become a developed country, how much they have to pay to mitigate their pollution, emitted pollution. So that and all discussed in lots of conventions. So I am going to show you what are the different conventions here. So this you can see: Convention on Long-Term Transboundary Air Pollution, Vienna Convention, Helsinki Convention, Montreal Protocol, Sofia Protocol, Geneva Protocol, Earth Summit, UN Framework for Climate Change, Kyoto Protocol, Gothenburg Protocol, Stockholm Convention, Paris Agreement. So it's are all based on their places where the convention or the protocol has happened, and the year was given here, and everything has its own purpose. Because as I mentioned, four major global problems like climate change, global warming, acid rain, ozone depletion, this and all was discussed in these protocols, and they come up with these ideas. We are going to see one by one. Okay, just this is in a year-wise ascending order, you can see here. So first was Convention on Long-Range Transboundary Air Pollution. So as introduction, I can see here, as we all know, air pollution is the fourth highest risk factor on premature death. Premature death, if you see, like first will be high blood pressure, second will be tobacco, third will be dietary risk, fourth is the air pollution. So air pollution itself causing this much death, premature death in the world. So 6.67 million death in per year, that is in 2019 itself. So think about the impact of air pollution on the human health. Okay, so what is the international environmental treaties? So international environmental treaties are the agreement signed by the countries to control, mitigate, and manage anthropogenic impact on the environment. Because people, human, we only created this impacts to the environment, so we have to sit and control this type of thing and control this impacts. Okay, so that's what international environmental treaties. Yeah. So here you can see the importance. Numerous environmental problems are already created due to air pollution like climate change, because our industrialization, our urbanization, our own greed has created this type of impact to the environment like climate change, ozone depletion, global warming, deforestation, acid rain. So that problems are addressed by transboundaries in nature and global issues, because that will not stay in its own place. That will have a transboundary. Transboundary means it will move from one country's boundary to another boundary. The air pollution don't know what is the country's boundary, right? It can emit, it can transport, it can be transported to any place, and only be properly handled through international collaboration. That's why this many agreements have happened. First one is the Convention on Long Range Transboundary Air Pollution. So long range transboundary, that name itself you can see, that pollution is moving everywhere. It's creating impact out of boundary. Okay, that's the problem. So what's the convention they discussed in 1979 itself? It's because why it happened in 1960, there was acid rain in the northern hemisphere. It damages forest. It has a fish population has decreased, putting entire ecosystem at risk. So they found out the reason is air pollution, released thousands of kilometers away, causes the harmful effect. It's not the air pollutant released in the northern hemisphere. It's from the 1,000 kilometer away. It has coming here through the transboundary movement and causes this much effect. So UNECE, that is the United Nations Economic Commission of Europe, has signed this treaty in 1979. All the European countries came into picture, and they worked to reduce this air pollutant, to reduce the acid rain. So it will include 32 countries in the European region, along with the United States and Canada, and the convention entered into force in 1983. This was the first international treaty. Before that, there is no international treaty for this type of environmental related issues. So, after this treaty, you can see here what is the impact of this treaty, effect on the convention. Emission of series of harmful substances has reduced by 40 to 80%. Think about sulfur. Sulfur, it was around 100% to, it reduced to 25%. Think about 100 to 25, how much reduction has happened due to one treaty itself. And drop in the emission reduced the deposition of acidified compounds. So acid rain has significantly reduced. There was, you can see, like very less asset is happening after this treaty. 1919 to 2012, you can see within 20 years this much impact. And the convention delivered concrete results. That's what I'm saying. Like particulate matter itself dropped, and sulfur got dropped by 30 to 80%. Nitrogen oxide has dropped by almost 80% between this 20 years itself. Then second is the Vienna Convention. First is 1979 is the Convention on Long Range Boundaries. So they signed to reduce all this type of pollutants, like sulfur is the major. Second one is PM. Second one is the Vienna Convention, first international convention to protect the ozone layer, because they identified ozone layer is depleting. The reason is ozone depleting substances like what we are emitting in the earth by the anthropogenic activity. Then they started discussing about this, how to reduce the ozone depleting substances. In 1985, they signed the convention, and it reaching the universal ratification in 2019. And protect human health and environment is their major aim, to adapt legislation or administrative measures against activities. So, Vienna Convention is focusing on ozone layer depletion, how to control. What's the key effect they have taken? The key result of this convention is restoring the ozone layer. You can see from which year to which year how the ozone layer is getting healed, or like it's said like a medicine. It's not healed. What are the holes that happened that got reduced? So fades out of ozone depleting substances under the Montreal Protocol. So Vienna Convention, they paved the way for Montreal Protocol. Montreal Protocol has phased out all the ozone. Phased out means removed or putting ban to the ozone depleting substances. What are the ozone depleting substances? What are the refrigerant we are using earlier, like chlorofluorocarbons, hydrochlorofluorocarbons, hydrocarbons. Now we change it to purely hydrocarbons as a refrigerant. So that's not having many, because only halogens like chlorine, bromine, fluorines, these are all having effect on the ozone that will easily oxidize the ozone. But this type of hydrocarbon, there is no impact on the ozone. So we are changing based on this Montreal Protocol only. Nowadays, people are changing with a different, uh, uh, like less ozone depleting hydrocarbons. Refrigerants. So this recovery is expected to occur before the mid of 21st century. They are expecting this, and then Helsinki Protocol. Like Vienna Convention is only for ozone layer depleting substances phase out, and then Helsinki Protocol, they are given a framework for formed by the Economic Commission of the Europe, same United Nations for Europe, and this protocol required at least reducing sulfur dioxide emission by 30%, because again they are coming with the acid rain condition only. So sulfur dioxide is a major point of interest, and they reduce it. The aim is to reduce by at least 30% compared to 1980s level. And parties required to take most effective measures for the reduction of sulfur emission and increasing energy efficiency and use of renewable resources, because only whatever the fuel we are using, that will emit this sulfur dioxide. So they want to have a cleaner fuel. After 5 years, sulfur emission was reduced by 20 to 23% after this protocol. And then Montreal Protocol, as I mentioned, Vienna Convention paved way for Montreal Protocol. Again, it phased out all the ozone depleting substances. So it's a global agreement, protected the Earth's ozone layer. They phased out all the production and the consumption of ozone depleting substances. All the refrigerants are got. Producing it's banned, consumption is banned. Signed in 1987, parties of the protocol meet once per year to discuss what are the steps they have taken to reduce this type of things, because at the on a single night we can't phase out all the things, right? So they have a aim. This year I have to reduce by 50%, this year 70%. So that and all they will discuss every year. So ratified by 197 countries, because this is a ozone layer. If it get depleted, whole earth will get affected. So all the countries came into picture, and they have signed this treaty. And then the protocol was amended 6 times, and most recent amendment was Kigali Amendment. So every year, wherever it's happening, that's based on the countries or the place name, the amendment will be called. So 6 amendments has happened in the Montreal Protocol. Kigali Amendment is one of the latest amendment of Montreal Protocol. So they phased down hydrofluorocarbon. HCFCs in 2016 is their agenda in Kigali Amendment. So you can see HFC phase out. That's one of the refrigerant. The batch of ozone depleting chemicals was replaced with the HFCs. They are potent greenhouse gases and thus contribute to climate change. So what's the effect of Montreal Protocol? After this steps has taken, you can see 1987, what does the ozone hole after industrialization and emission. Now 2016, the ozone hole got healed. And COVID time also, you can see it got healed very rapidly. It got healed because of no vehicle, no industry operation. and ozone depleting substances that are ODS, including chlorofluorocarbon, halogens, methyl bromide, because all are halogens, and hydrofluorocarbons. Again, chlorine is there. These are all got phased out. Antarctic ozone level got expected to return its own level, whatever there in the 1980s. That will be expected in 2050. So ozone layer is on its path to recovery. Then Sofia Protocol. That was again by the Economic Commission of the European Framework. All the European countries has that's the place in Bulgaria, and it came into force in 1991. So their aim is to address the nitrogen oxide. So a NOx is their aim. SOx is one of the aim in earlier protocols. Like Sofia Protocol was only for NOx emission from the transboundary fluxes. So that introduces pollution control measures and the significant existing stationary sources and applying national emission standards to primary new stationary mobile sources. They are applied in all the like stationary, mobile, and existing stationary sources. They created uh, what we call standards, stringent standards. So reference level they have taken is 1987. So from that, how it got increased or reduced, that's what they have addressed. So 5 years, NOx emission was around 11% lower after this protocol. Yeah. So if you think about Geneva Protocol, that is in 1991, that focuses mainly on the control of emission of volatile organic compounds. Why? Volatile organic compounds again, uh, it created what? Responsible for formation of ground level ozone. Because what we have discussed, the ground level ozone is uh, stratospheric ozone is good for Earth. Ground level ozone is uh, it will affect the human health. So that will be formed from whatever the volatile organic compound we are emitting and whatever the NOx that is emitted from the vehicles. So that both will contribute to the formation of ozone in the Earth surface. So you all know like NOx plus VOC will give you ozone at the ground level. But at stratosphere, you all know O2 plus O will give you O3. Again, that will be converted back to O2 plus O. So that is a standard happening reaction happening in the stratosphere. That will automatically shift on its own. But whenever we are emitting a NOx, that will go and capture this O, and that will not. I mean, sorry, capture this O3, and that will be converted back to O2 and O. So that is the problem of not forming the ozone. That's why the hole is formed. But the same is happening in the ground level. It's forming the ozone that is creating pollution. The ozone is a highly human carcinogen. Okay. So if you reduce volatile organic compound, you can easily reduce the formation of ground level ozone. That was addressed in the Geneva Protocol. Yeah, okay. So Geneva Protocol after this, but the effect is decrease of by 30% between 1984 to 1990. And after 5 years, you can see as a 1987 as a reference level, 15 to 80% lower. Difference was 19 to 20% 10 years after the intervention of this protocol. Then Earth Summit happened in 1992. That was happened in Rio de Janeiro. You all know Rio Earth Summit in 1992. That was spoken worldwide and with 177 head of states and 178 countries. So its main aim is the Convention of Biological Diversity. All the problems were addressed. Only with the Global Warming Convention was binding treaty that requires nations to reduce greenhouse gases, because global warming is due to emission of greenhouse gases. That was addressed in the Earth Summit. So after that, only 1992, you can see all the textbooks they are talking about greenhouse gases that need to be reduced, global warming, climate change. That words and all came into picture after Earth Summit only. Okay, so you can see Rio de Janeiro, they established 27 boats. You can see this is the first picture. You can see Earth Summit's 1992 picture. After that only they are talking about the greenhouse gas emissions and reduction. And Agenda 21 established worldwide initiatives and statement of principles on forest protecting world's fast disappearing tropical rainforest, because that can absorb this type of carbon dioxide, right? So that need to be addressed. Then UNFCCC, like framework for United Nations Framework Convention on Climate Change, that's related only on the climate change problems, because it's again developed from the Earth Summit only and ratified by 197 countries. So how to prevent dangerous anthropogenic interference with the climate change? So all the global warming related things are related with the climate change, and developed countries agreed to adopt the national policies to mitigate the climate change. That's the important thing, and return to their 1990s in level of this type of air pollutants, I'm saying. and then data about the domestic greenhouse gases emission that need to be shared by the countries, and all parties are required to submit the national greenhouse gas inventories means how much pollution they are emitting. All the countries should submit to the UNFCCC, and then developed countries must submit more detailed description of mitigation policies, because they already emitted lots of global greenhouse gases that need to be reduced, and what are the steps they have taken, that detailed description need to be submitted to UNFCCC. And then Kyoto Protocol. Kyoto Protocol happened in 1997, mainly to address the reduction of greenhouse gases. Because Earth Summit is talking about the climate change, as I mean whole global warming, and UNFCCC are based on greenhouse gases. The same was targeted by Kyoto Protocol. That was the first commitment period, 2008 to 2012. They targeted first 6 major greenhouse gases like carbon dioxide, methane, N2O, HFCs, PFCs, and SF6. And by at least 5% relative to 1990. That was their target. And Kyoto Protocol amended in 2012 in Qatar, and to reduce the greenhouse gas emission by at least 18% below 1990s. That was their major aim. That was discussed here also. So the protocol offers 3 market-based mechanism. One is international emission market-based mechanism. Here itself, you can say there is a business behind this. What we say, like greenhouse gases emission. So first one is international emission trading, second one is green development mechanism, third one is joint implementation. All are interrelated, you can see. First is international emission trading. So all of you may know about the carbon credit. You all are using the credit cards that may have a fund already existing in it that you can use to get some money without spending. You can pay later. So I am polluting, I am paying later to compensate my pollution. That's called carbon credit. Because if I am emitting 1 ton of CO2 per day, I can plant 2 trees per day. So that can compensate my carbon dioxide emission. So that's called carbon credit. So every industries are nowadays having this type of carbon credits. So they have to submit this reports to the pollution control board, how much carbon credits they are having. Or they can even sell the carbon credits, because if I am an NGO, I am planting 1 lakh trees per day, per month or per year. So I have some carbon credit, positive carbon credit. Some industry which is polluting, that may have negative carbon credit. So they can buy my carbon credit by paying some money. So that's what the industry is paying money to to those who are having positive carbon credit, and that carbon credit will be compensated with their pollution. This will work out like logically. So that's specified in the Article 17 of Kyoto Protocol. Kyoto Protocol only given these 3 trading options. Allows country to sell their excess emission units. Because if they are one equivalent unit, 1 unit of carbon credit is equal to 1 ton of carbon dioxide emission. That you please note down. Carbon credit is very important. And Sweden is having the highest carbon credit of $139. A new commodity was created, because carbon credit become a product right nowadays. So a new commodity that was created in the form of emission reduction. Yeah. So now you can see clean development mechanism is another article in 12 that was in the Kyoto Protocol. So countries with an emission reduction or emission limitation commitment under the Kyoto Protocol to implement an emission reduction project in developing countries. So those countries which has already polluted, become developed country by pollution, they have to implement some strategies in the developing countries. That's called clean development mechanism. And in the third article of Article 6, they have joint implementation. Nation with the emission reduction under the Kyoto Protocol to earn emission reduction units from a emission reduction or emission removal projects. See here, developed countries need carbon credit. Another developed country B. So they set a project here, and that earned carbon will be sold to this developed country A. You got it? So they will have if United Nations they are spending to create some forest in India, or helping to plant trees, or any carbon capture mechanism, or reducing this type of carbon credits. So one country is investing on the other country to earn carbon credits or to sell carbon credits. That's called joint implementation. All the 3, if you see, are interrelated only. Based on carbon credit, you can sell, you can earn. Okay. Yeah. So after this Kyoto Protocol, what is the effect? You can see red mark, a tragic reduction in the greenhouse gas emission, about 17% less than the non-Kyoto Protocol scenario. So they have a scenario, if Kyoto Protocol was not there, this much emission of will be there. After having the Kyoto Protocol, this much emission is there. So that is a prediction. This is the actual. So you can see 7% less than the non-Kyoto Protocol. So this much of log of carbon emission. Then Gothenburg Protocol. They have that was in amended in 99. I mean, first was in 1999, and that requires the parties to control and reduce the emission of four pollutants, that is SOx, NOx, and volatile organic compound ammonia. So they set limit value for specific emissions. So they have a again they reduce, each protocol has a, they come up with the stringent standards. Earlier it was 10 microgram per meter cube. Later they have converted to 5 microgram is the maximum limit. So industries have to have a mechanism, or they have to create their process accordingly. They have to modify accordingly to have less reduction, less pollution emission. Yeah. So VOCs emissions from such products like paints and all have to vanished. And farmers, they have measures to control ammonia emission. And then this protocol amended in 2012, that includes nation emission reduction to be achieved by 2020 and beyond. They also included the fine particulate matter after the second amendment, and reducing particulate matter, including the black carbon, through the implementation of this protocol. You got it? And then Stockholm Convention happened in 2001. That's a global treaty to protect persistent organic compounds, POPs, persistent organic compounds. You all know what is persistent organic compound. That is from the agrochemicals or industrial chemicals that will not go by treatment. So because whatever the conventional water treatment plant we are having, that will treat our basic biological contaminants. But this type of chemicals, agrochemicals are all that cannot be treated by the conventional treatment plant, that will come out with these effluents, and that will mix with the river, and that will be accumulated in the human health or any ecosystem. So that accumulation will happen. So this persistent organic compounds are the pollutants are the reason for bioaccumulation and biomagnification. Okay, that remain intact in the environment for longer period of time. That's the problem. So Stockholm Convention is only focusing on this POPs. We can see POPs are emitting, and then it will be accumulated in all the organism, and it will be finally entering into the humans in a highly concentrated level. And over 150 countries ratified in this convention, and the five essential aim is eliminate dangerous POPs because it's very dangerous, and supports the transition out to safer alternatives, target additional POPs for action, clean up old stockpiles and equipments, work together for POP free future. So that's what Stockholm Convention's five major aim. So it sets up a system for tackling the additional chemicals identified by the unexpectedly hazardous. So currently these regulates 29 POPs, and requires parties to implement various control to reduce and wherever possible and eliminate the POPs emission. Okay, so they identified 29 as a major thing. Yeah. Then Paris Agreement. Paris Agreement is only on global warming again. So it's the United Nations Paris Climate Agreement. That was also spoken worldwide 2016, and they got 21. That's a conference party, COP21. So adopted 199 countries at the COP21 in Paris. So every year they have a conference of parties. Not only every year, like periodically they have conference of parties. Latest we have a conference in I think UAE, that is a COP, latest COP, and its goal is to limit the global warming to well below 2 degrees Celsius. Okay, so that's the aim, and preferably 1.5 degrees Celsius compared to the pre-industrial levels. You got it. So pre-industrial level, that is in 90s, 1900, that was the start of industrial era, and 2000, this century was called as industrial century, and before this there was a temperature, right? That was our original Earth temperature. Here you can see there was a sudden rise to 2 degrees Celsius. So that need to be reduced to a level pre-industrial level. That's what our aim in Paris Agreement. So they aims to improve the ability to deal with the effect of climate change. And what's the reason for this rise? Due to the emission of greenhouse gases that traps the sun's heat into the earth itself. So that need to be vanished. So again we have to come with the greenhouse gases only. That's the air pollutant. And then enhance the transparency framework for action and support, and 5 year cycle of increasingly ambitious climate change by countries. Yeah. And nationally determined contributes NDCs, how much they are contributing every nation to address this global warming, and established a vision of fully implementing technology developed and transferred to improve resilience to climate change. That's why nowadays all the proposals, research here once we are coming, all the researchers, we what we are doing, we have to have a technology that should be fully implementable technology in the field. Only research will not work out. That need to be implemented in the field to reduce this type of climate change impacts. Okay, and lower the greenhouse gas emission, so that we can achieve the 2 degree reduction in by 2050. Okay, yeah. And after this Paris Agreement, you can see strongly emphasizing climate-related capacity buildings for developing nations and lower carbon solution, carbon neutrality targets they had, and zero carbon solutions. More than 70% of the global emission by 2030, they are coming up with. Yeah. So all this international treaties, what they are saying, air pollution and greenhouse gas emissions are global issue. That's what they identified first itself in 1990 itself. After 90 years only, they say, okay, what we are emitting, it's affecting globally after seeing the ozone hole. So various attempts were made globally in the form of international treaties aimed in reducing the air pollution. All are rolling around air pollution only. Now you can able to imagine, right? So through technical interventions and resources sharing with the other countries, that's what important. Money need to be shared and technology need to be shared so that as a united nation we can combat this type of global issues, environmental issues. Yeah. So here comes interesting part: impact of lockdown on the air quality. We all know like COVID, we are affected by last 2020, 21, 22, and all. We have affected in India. All the 3 years was three lockdowns we have had, right? So what is the impact of that lockdown on the air quality? Do you think it will be improved or decreased? Hopefully it will be increased because all the vehicles are shut down, all the industries are shut down. So there is no much emission, so that resulted in a improvement of the air quality, and healing of ozone was another study that you can see some of the papers were published, and we are going to discuss some of the case studies. Okay. Yeah. You can see here COVID-19 as one of the biggest global public health emergency we had. We are on that era at that time, and threat of COVID-19 spread global health emergency, and lockdown has happened in major countries, the whole countries, and led to massive economic loss to the world. That is one economic loss. Still more countries are struggling, but India has come up within 2 years. It has reached the original level, and however it has a relief to the environment. That is what important point. Even though we are struggling with the economic losses, we had a good relief to the environment. Whole earth is breathing at that time when we are not able to breathe. So effects of lockdown on the air quality, you can see in New York City's mist level, and Spain's Barcelona before and after, and Taj Mahal in Delhi, you can, sorry, India Gate in Delhi, you can see how the improvement has happened in the air quality level. So restricted vehicle movement, closure of industries and other activities, this is the main reason during the lockdown for the reduction in the anthropogenic emission, because no people is coming out, no human related emissions, and improved in the air quality of many cities worldwide. So first case study you can see in Sao Paulo in Brazil. You can see the data was analyzed for 4 air quality stations. You can see the urban road 1, 2, city center, and one air quality station in the Botwood. So these are the four air quality stations. They have observed the data, daily data from February, March, and April on the year 2015 and 19. That was the lockdown period of Brazil, and you can see the nitrogen concentration reduction. 27% compared to the 4 week before the partial lockdown. So they have partial and full lockdown. So before that there was a nitrogen oxide level that was reduced to 27% and 45% compared to the same period in 2019. You can see here all the pollutant like carbon monoxide, nitrogen oxide, nitrogen dioxide, all are reduced to around 50 to 77% also they have reduced. So that much emission as that much reduction in the major pollutant. But only one culprit here, ozone, ground level ozone is getting increased. Why? Again due to the problem with this nitrogen oxide. So that's a major problem again contributing to the because whenever nitrogen oxide is there, that will destruct the ozone, right? As we had seen in the stratospheric ozone also. If there is no nitrous oxide, then the ozone level is getting slightly increased. So 30% increase also they have observed in urban areas, because whenever there is some nitrous oxide, whenever it's combining with the VOC, ozone will be produced, but some nitrous oxide will destroy ozone. So that is not happening in the ground level. So that is the reason for increased ozone concentration in the ground level ozone concentration. So all the case studies, if you see, ozone will be getting increased. So road traffic accounts for 68 to 98% of NOx and carbon monoxide emission respectively. So see here, so this now NO will always merge with CO3 and NO2 will be formed and the O2 will be oxygen will be produced. But this is not happening because vehicle is not emitting NO, so ozone level is getting increased. That's the problem. So by contrast, an increase in the ozone concentration in the urban areas highly influenced by vehicle traffic was observed. So ozone concentration increases, due to the decrease of NO, decrease in the ozone consumption, that leading to the higher ozone concentration in the ground level. That is one of the problem, because ground level ozone is human carcinogen. Second case study is northern China. You can see they have a air quality index for SOx, PM 2.510, and NOx and carbon monoxide. 40 the city were taken. They were in the lockdown in China from January to March of 2020, 81 days. So they have observed the air quality data. Human mobility dropped to 70%, and the air quality decreased by 7.8%. Air quality index has decreased. So whenever we have less index, that is good, right? So if the air quality index is higher, that is bad for the environment. So they have air quality index decrease of 7.8 percentage. Then in the northern China, they have suggested the implementation of travel restriction dramatically reduces the air pollution that they have identified, and they are in the 42, 44 cities. And later after lockdown also, the post lockdown also, they have implemented the same strategy, restriction in the travel, that could able to improve the air quality. Okay, that was the learning. Then in the Europe, you can see impact of the control measures during COVID-19 lockdown. Uh, NO2 level got decreased, ozone level got decreasing only in Liberia, but other areas it got increasing. Okay, and low NO2 concentration. That is the reason for increased ozone level that we have already discussed, and the meteorologically adjusted NO2 decreases are larger. What is meteorologically adjusted NO2? Because whenever there is a stable condition, that NO2 dispersion will get reduced. That's called meteorologically adjusted NO2, that is getting decreased. Meteorological effect contributes to lowering ozone in Liberia alone, and other regions is getting increased. So that why this is only ozone level is increased not only because of NO, but also due to other factors, meteorological and geographical factors like elevated temperature in British, that can also contribute to higher ozone level, low specific humidity, elevated solar radiation. Because solar radiation UV contributes to the production of ozone, right? So from the sun, whenever the UV is there, then only ozone will get produced. So that may be higher during this COVID lockdown time. So that also contributed to the increased ozone concentration. That's what the study says. And Italy, you can say a new ordinance for the authorities released in the closure of all schools and place. So partial lockdown and then total lockdown was happened. So 9 pollutants was observed, and their results were like PM 2.510, BC, benzene, and carbon monoxide and NOx were studied. There is a significant reduction has happened in this 6 pollutant, and the sulfur dioxide remains constant. Why? Because only in the more peripheral areas, there is still the movements are happening during the lockdown. So SOx remains unchanged, and some of the industries are happening illegally. That's what the reason for SOx level. And part of ozone is increasing. That was probably due to the lower NO again. And carbon monoxide reduction due to decrease in the vehicular traffic, due to the use of reduction in the use of household heating. That is another major absorption we have got. That's why they are after COVID also they are using the same strategy. Household heating requires lot that emits lots of CO levels. And the SOx reduction in Milan can be partially attributed to the decrease of heating. Yeah. So house heating in Italy contributes to lots of SO2 and CO levels in the atmosphere. Then significant lowering of NO concentration reacts with the O3, leads to the obtained highest O3 concentration. That is obvious again. And Spain, if you see, lockdown from March 14, 2 weeks lockdown, restricting social contact, reducing public transport and closure business. So they have seen all this pollutant data, and they have come up with this NO2 and BC, that is black carbon concentration was reduced, and PM10 decreased, O3 got increased. That is one of the again issue. And decrease of the NOx in VOC limited environment. Decrease in the NO reduces the ozone consumption. Again, the same slide. Yeah. Then USA, if you see, particulate matter and NO2 was observed from 2017 and 20. This many years they have observed. That is a pre-COVID and post-COVID period. And difference in the historical and current data, you can see reduction of 5% and 25% during the COVID period. So that was the reduction I'm saying, percentage change. And decreased NO2 are likely associated with the reduced vehicular traffic. So all the vehicle, if you shut down, no NO2, no car SO2, no CO. So these are all the. That's why nowadays we are starting e-vehicles, and this catalytic converter or most of this three parts where the emission is happening from the vehicle. One is from the tail, one is from the uh, uh, fuel tank, and another is from the this aperture, right? That engine. So that three has been emission has been controlled by different strategies. That also we have catalytic converters, uh, like filters, and all the strategies we can follow, or we can also reduce this type of fuel-free vehicles like e-vehicles we can follow. That is a good option finally. So percentage change in the PM is not as large as compared to NO2. In India, if you see lockdown period, overall impact of social and travel lockdown, spatio-temporal variation, five criteria pollutants they have observed over two time periods. Because first lockdown, before lockdown and during lockdown, that is in 2020, and during lockdown is March to April, they have observed that is a pre-lockdown. Phase one is the lockdown, and then in the phase two that allowed only the farming activities. Phase three they allowed again three zones categories: red zone, orange zone, and green zone. There is a relaxation, and again phase 4 movement of vehicle they have allowed. So all this phases how the air quality has improved and decreased, that are all they have discussed here. You can see every phases how it Delhi showed the highest reduction in the PM 2.5 because they have earlier higher PM 2.5 levels, so that got fully reduced, and Mumbai showed the highest reduction in the NO2 level. In contrast, other pollutants like ozone increased due to the reduction in the NO level. Yeah. So in India, contrasting trend of O3 may be due to more favorable conditions like photochemical reactions attributed to the increased solar insolation, decrease in the NO2. Again, solar radiation causes ozone increase. And 30 to 50% of NOx emission are released by vehicles, resulted in reduction of NOx emission. Volatile organic carbon limited environment lead to, because whenever there is no vehicle, VOC limited environment. That's what we will call VOC limited environment, lead to increase in the ozone concentration. Yeah. Then NOx reduction measures the urban centers, increasing the ozone concentration due to titration chemistry. Sector-wise sensitivity analysis also they have done. Yeah. And stubble burning, that is another major issue. Stubble burning is what are the agricultural waste, the farmers are burning. That is again causing major PM level increase. Another reason for lesser amount of reduction in the pollution concentration is southern India compared to northern India. That is one of the major observation. So learnings from the lockdown, lockdown cannot be a long-term or permanent solution because we can't shut down all the industries and vehicles because we have to be a developed country and we need development. So for that we have to use all the industrial experts, and but that need to be a sustainable way without creating impact to the environment. How to be a developed nation, that's what we have to look into. So lockdown will not be a permanent solution. To revive the economy, various sectors would resume operations sooner or later. So post lockdown, the current air quality index may reach alarming higher levels due to the weather conditions. That's what post lockdown region. So alarming levels within 6 months after lockdown itself, it got reached the same level what we got before 2020 and all. Okay, so that's what the learning. Again, national in India, you can see the National Air Pollution Health Programs, that is NPCCHS, and NCAP has collaboratively created a strategy learned during the COVID-19 lockdown that protects the population and air pollution. So other policies such as like you cannot make a lockdown as a permanent solution, but work from home you can use, that can reduce the transportation impact, and online classes, virtual conferences, telemedicine, and digital banking. So these are all the steps or strategies taken to reduce the impact of air pollution. Okay, so the spread of COVID-19 disease simulated a global health emergency, forcing strict measures such as lockdown. And emissions were reduced as a result of lockdown, provides an opportunity for local and regional authority to gain a better understanding. Because that is an opportunity. What we learned from the lockdown is an opportunity to form the strategies with the government. Yeah, you got it. So in the third lecture, we are going to see about how sector-wise mitigation measures to control the air pollution. What are the sectors? Like transportation sector, residential areas, industrial areas, agricultural sectors. So how to control this air pollution by sector-wise? Okay, we are going to see urbanization, transportation, industries, power generation, and agricultural sectors. Okay, and other mitigation measures also we are going to see. This all will be repeated only, but see, think about the overall perspective. How can we frame a solution for this type of or mitigate this type of air pollution? So Indian cities, including New Delhi, has ranked as the most polluted cities in the world. Several cities in India violate the prescribed standards of ambient air quality. This is again a sad news about India. So most of the cities in India are coming under world's most polluted cities. Yeah. So sectors like urbanization, transportation, industrialization, power generation, and agricultural activities are need to be considered, and mitigation measures are framed. So for urbanization, if you see city planning and management, so that will reduce the transportation, or you can say, as example, I am saying, if you are going through the city for your school or colleges, instead of that, if there is a bypass to reach, so that will reduce the emission, and that will also reduce disperse the pollutant. So that is one of the option. And allowing of for heavy vehicles during night time only, so that may also disperse the pollutant and reduce the traffic congestion. So city planning is a major plays a major role, adopting a balanced sub-regional approach with integration of mass transit, reducing trip length, motorized travel, and urban sprawl. So trip length need to be reduced. If I want to go from one place to another, the city need to be planned accordingly, and land use planning with plans of reduced population density. So if all the population are congested in one area, if you take Tamil Nadu, most of the population are going with this Chennai, metro cities like Coimbatore. So these are all industrialized area or IT sectors. So people are going there, and there is a dense population is happening in a smaller region. So that need to be planned again. There is a need for city planning again. Okay, so reducing the exposure to the pollutant releases from the industries. Then supply of cleaner fuel. You can see Pradhan Mantri Ujwala Yojana. That is a scheme introduced by the Prime Minister. That's the LPG gas. We are all transferred from biomass cooking burning to LPG gas burning for our cooking purpose. So that reduced drastically the release of particulate matters. So the government schemes such as PMUY, that is Pradhan Mantri Ujwala Yojana, that increases the LPG access across India, successfully enhanced the use of cleaner fuel, because it's a cleaner fuel. There is no emission we are getting right from the kitchen, and more efficient use of biomass, improved stoves with efficiency of 30 to 40% as compared to 8 to 10% of the traditional cooking. And solar light option for rural areas, instead of that lanterns or kerosene, we are going with the solar lights. That is another mitigation measure. And improving collection efficient segregation of solid waste, because the burning of solid waste, as I am working on solid waste management, I know burning of solid waste, how much impact it will create. So proper collection of segregated solid waste is a major part to reduce the dumping of solid waste in the old dump sites and burning of solid waste in the dump sites. Okay, so enforcement of complete ban of refuse burning. Refuse is whatever the thing solid waste I am saying. So ban on refuse burning. So solid waste management rule 2016, even 2000 itself talking about the ban for refuse burning. Wherever you can see the waste is getting burnt, that you can easily complain to the Tamil Nadu Pollution Control Board or any, I mean, State Pollution Control Board. Like strictly enforced with the substantial penalties, develop a mobile application, so there they can put complaints. So winter shelters with heating arrangement for homeless people, that need to be set up. And waste to energy option. So that can, instead of waste simply burning in the environment, incineration is a good option. Burning and incineration are same, but the burning is happening in a controlled environment, so that there is no emission into the atmosphere. The air pollution is getting treated before emitting into the atmosphere. That's why burning in a controlled environment is called incineration. So that will also help in creating energy for future from the waste that is getting burnt. So we have to create a waste to energy options like pyrolysis, gasification, incineration. These are all new technologies that are not new, so old technologies that we have to adapt. And maintaining quality and cleanliness of road, that will also reduce the emission. That is like a fumigative emission that we will say from the road, whatever the emission is happening, that need to be controlled by vacuum cleaning devices. And dust control at the construction areas, because construction sites are responsible for major higher big size particle emissions. So usage of trees and shrub, that will act as a, not only act as a carbon capture, also act as a particulate matter capture, enhancing the moisture content at the site by using fogging system, that is like spraying water at high pressure in the form of mist, that will control the particulate matter. It will absorb the particulate matter and settle at the ground. And like what we are using every day morning, we are sprinkling water in front of our house, that will also reduce the emission of that's emission of particles from the ground. So that is one of the air pollution control techniques. So like that only you have to spray water, that will help in reduction of the emission. And prefabricated material, that can also minimize the cutting, grinding, and drilling in the open area. Avoid shift, improve. So we have completed with the urbanization. These are all the techniques. Now we are going with the transportation sector. In transportation sector, these are the three major approach: avoid, shift, and improve. So first, what we have to avoid? reduce the travel demand. If I want to go to like I can reduce, right? If I am going to the same place for daily, I can make it into odd days or even days. That may be reduced. So unwanted the travel demand need to be reduced and shift from prioritizing public or non-motorized vehicles mode or private motorized modes. We have to change. So I am having own car. I should not go in my car. I have to rely on public transport or any non-motorized vehicle. I can use my cycle instead of my bike. So that are all shift. Then improve, enhance the quality of the fuel. Instead of burning petroleum fuels, you can go with e-vehicles or bioethanol or methanol. This type of things are coming nowadays. So that means change in the fuel or enhancing quality of the fuel technology and strengthen the system of pollution control. So this avoid, shift, and improve is the major strategy for transportation sector air pollution control. Okay. Then travel demand management, the TDM is a major uh, uh, term in transportation sector. Travel demand management. So Ministry of Urban Development they have suggested the planning and implementation of TDM measures as a part of comprehensive mobility plan in India. So nowadays all the urban mobility or transportation was planning or based on the sustainability terms only. So again, environmental plays a major role in all the sectors. Like buildings need to be constructed as resilient buildings need to compact all the climate change like flooding or drought, and transportation sector need to be this type of sustainable mobility. And then what are the other sectors in civil engineering or any related things are all related to environmental engineering like sustainability. Okay, then vehicular ownership control can be implemented through vehicle quota system and taxes and insurance. So one people can hold only one car, that may be enough. If you want two more cars, the taxes should be increased and insurance need to be increased. And usage control in the form of road space rationing, because I am if from a home, if two people are traveling to the same place, they should not come in two vehicles. They can share one vehicle, right? So that need to be controlled. That's what rationing. How to use a road. So if I am having 5 meter wide, I could not accommodate five vehicles in that road. So that need to be properly planned. That's got a sustainable mobility. And then public transportation. See, if you are, I can show some picture from I have seen in Facebook or Instagram, the LinkedIn also. In a road, if you have one bus having 60 people, instead of that, each people are going in single car, 60 cars. How much it will accommodate? Think about 60 cars. So that cannot hold in the same road, right? How much pollution it is emitting? How much pollution it is emitting from 60 cars? So that are all you can compare. You have to shift it to public transportation. That behavioral change is very important. 90 to 90% reduction in the emission of all this pollutant and 50% reduction in the carbon dioxide and NOx level. Think about the huge emission reduction when we are using the public transportation. That's why all the metro cities nowadays we are going with the train, bus. In Tamil Nadu, mostly we are using public transportation. If you see Chennai, because cheaper. That is main important. If your public transportation is cheaper than your private vehicle, people will adopt to public transportation. Another one is behavioral change. People should be uh, adapt to use this type of public transportation system and shift people from private modes. A non-motorized vehicle, here again it's related with the people's mentality. And also government should have a proper planning. If I am using cycle, I have to have a highway separate cycle lane, then only I can use cycle, because I can't go without cycle in highways, right? So that is the problem in India. Using cycles in the highways are banned. So that need to be, you can see some of the case studies from other countries, how they are using. So non-motorized vehicles, that is also people's mentality, also based on how the planning was happening. So good shade should be there, then only I can park my cycle. Bike parking facilities, road crossing priorities. Because if only the cars are crossing the roads, where can I go with my cycle? And cycling in Indian cities need to be encouraged. Yeah, like Paris, Amsterdam, London. This are all I'm going to show in the next upcoming slides. And fuel quality and vehicular emission norms. Auto fuel policy in 2003 by Government of India. Auto fuel policy. That's a cleaner fuel and vehicles. So you can see like BS1, BS2, nowadays BS6. That from 2010 we are having BS4. This is the Bharat engine system. So we have to change modify the engine system accordingly to use or emit lesser pollutants. So we have directly transferred from 2010 to 2020 with BS4 to BS6. So there is no BS5. So there are modification in the engines. Yeah. Yeah, here fuel quality and vehicle now emission norms. Again, Ministry of Road Transport and Highway, they have changed from BS4 to BS6 and reduced the vehicular particulate matter emission to the lowest possible. Yeah. if you are using e-vehicle, there is no emission, zero emission. Yeah. Use of bioethanol and compressed natural gas, CNG gas. Nowadays, most of the vehicles are. I mean, in Trichy, I am seeing lots of gas stations. Gas station is not this type of petroleum fuel gas. I'm saying like ethanol gas or compressed CNG gas stations are there. E-vehicle charging stations I am seeing. So this are all people are changing nowadays. So that will also contribute to lots of emission reduction. But where the electricity is getting generated, that need to be again addressed, and that need to be controlled environment, because if your vehicle is emitting in the road, is not comparable with the industrial industry that is producing coal based energy, or thermal based, I mean nuclear based, or hydro based energy. So that need to be, there is a difference, right? So the same emission only happening, but it's in a controlled environment. So that's what the difference between using e-vehicles and fuel based vehicles. And inspection and maintenance programs, I and M, that need to be happen in India. It's not foolproof, and allows pass through without process, proper checking all the because I am seeing most of my friends are having bike with lots of emission that need to be addressed, because all the pollution control board having norms not to use with the proper testing only, you have to have a vehicle. So that pollution control norms need to be taken care, IVCP. That's what the in-use vehicle compliance program, that strengthens the inspection procedure to address the risk of high emitters. And congestion, if you have lots of congestion, again lots of emission, lots of fuel. So odd even schemes may be considered. Delhi nowadays they are having, right, number plate with ending of odd number, they are going in odd days, and number plate with even number, they are going in even days. So traffic signal improvement need to be there, so that our signal free zones like Roundana or roundabout, or any other flyovers, so that we can minimize the signals and people can go directly without loss of fuels, and no more excess emission. And converting two-way traffic to one-way traffic, and imposing left-right turn restrictions on two-way streets, so that people can easily move on like expressway. And incident management systems to manage traffic during any accidents, like IT based application, carpooling system. Carpooling, if you are from same apartment and you are going to the same office, so people can share their vehicle, that is called carpooling, right? That may work out lesser emission, like all three people, instead of using single cars, you can three can go with a single car. Purchase of new vehicles could be made conditional on an older car being scrapped. You cannot use both the vehicles, that need to be implemented by the government. And transit bypasses, as I mentioned, bypasses are good, instead of traffics that can reduce the emission. Construction of bypasses allows the vehicles to smoothly bypass, reduce the air pollution load within the city, and avoid city congestion. Yeah. And road to rail flight movement improvement, you can see sharp increase in the energy demand from heavy duty vehicles. Sharp share of railways in freight movement need to be improved. Freight movement, I'm saying like couriers and all. An initiative from railways to improve door to door services. And electrical mobility, there is no tailpipe emission, that's what important. I can say there is no emission, there is no tailpipe emission. And NEMMP to 2020 aims to promote electrical mobility. Public transport system also need to be planned hybrid or electric mode. So all the car can be used with petrol or diesel along with the electricity. And electric mobility tackle the highest cost of electrical vehicle, faster adaptation and manufacturing of electrical vehicle scheme under NEMPP, and incentives buyers for purchasing. That is very important, because capital cost is higher for this type of vehicles. So if your government is giving some incentives, I can go with my vehicle. And environmental taxes need to be waived off. Higher registration tax can be used by the government to promote low carbon fuel efficient and vehicles, and penalize inefficient and polluting vehicles. And vigilance and enforcement, urge, this is after transportation sector we are coming with the industrial sector. So there need to be a vigilance and enforcement, urgent need to enforce the existing standards to the industries, because industries cannot emit whatever they want. Inspection and monitoring, that is already happening, still we need to have a stringent standards. If they are emitting 10, I can restrict to 5. Change your system, change your process. So that's process modification is very important. That's called green chemistry. There is no emission. Nowadays we are going. Tamil Nadu is having zero liquid discharge, ZLD. There is no water is coming out of industry. They have to treat on their own. They have to reuse for their own. So like that, solid waste management, there is a scheme like that. Air pollution also we need to have a proper monitoring and this type of schemes. Reduce the scope for pollution, and the continuous monitoring and online reporting need to be there. Cleaner gasless fuel, that is second option for industries. So at least in and around highway highly polluted cities, that should not be there. and incentive-based programs switch towards cleaner future. They also should not use coal. Like cement industries nowadays, they are using waste as a fuel instead of coal. So it's mandatory in India. 5% of their fuel should be from waste. So that are all new schemes, good schemes. And online monitoring that is also having emission, but still your fuel is getting reduced, right? And installation of web cameras in highly polluting industries and stack monitoring standards in place for PM and PM emission standards for new and improved stock emission standards. Stock emission will only measure PM and SO2, right? Majorly, and that need to be all the small scale industries need to have a quite relaxed. That need to be addressed. Okay, you have to. It should not only concentrate on bigger industries. If you see a lakh or 10 lakhs small industries, small scale industries are there in each cities. That need to be monitored because one meter cube per day in one small industry into 10 lakh you can multiply. It is not even equal to bigger industry. So you have to target small industries emission also. You need to revise the PM standards, and there is a no need for development of emission standards. Yeah. And then power generation. If you see that power generation as a sector, you have to go with again renewable energies. The generation of power efficient, clean, and sustainable need to supply 24 by 7 to lower the usage of diesel generators. And tackling emissions from coal-based industries by strict monitoring and maintenance ensured for better control of PM emissions. Yeah. And then you can see tackling emission by here also again gas desulfurization before emission. These are all control strategies after industrial production, like with the coal power plant. Whatever the gas that is emitted, that need to be, it's a new technology. Flue gas desulfurization should be made mandatory to control the sulfur emission, and stringent emission standards need to be set for NOx emission also. And agricultural activities is another last sector. So there, state and national level procurement agency for agro residual procurement that need to be set up, and Prime Minister Employment Generation Program along with the Mahatma Gandhi NREGA. So they have an institution link setting up biomass depot facilities. So agriculture, they are all burning, farmers are burning like waste crops that need to be taken care. So we can whatever the briquette techniques, like under my guide, lots of research scholars or our research group is also working on briquette production, like briquettes from the biomass that need to be encouraged with the small scale farmers. So policy provision for financial incentives and other scheme use of biomass briquettes, and that could create 30% to create the demand of fuels. And generation of electricity is one of the attractive options, like biogas from their cow dung and all we have to encourage. And sector wise, again, agricultural sector dedicated policies to encourage crop residues from the power generation. You can see like crops, like nowadays also we have written a proposal from lots of crops like tapioca and all you can use for ethanol generation. So most people are coming up with this type of crops or sugars that need to be gone with the energy production, ethanol production, conversion to value added products. The R&D here comes, we are coming like research and development need to be there. Yeah. So other mitigation strategies, we can monitor networks to be implemented, and we have MOFCC and CPCB to monitor, and source apportionment studies are need to be conducted. Which sector is contributing more? So that's what we source apportionment studies we have already seen in the fourth week. So you can see coal, dust, open burning, diesel and petrol, transportation, biomass burning, and industries. So you can see industries are contributing only 1%. Others are from this type of energy production and burning only. So that need to be taken care. Yeah. An air pollution management plan, AMQ, drafted by designated institutions, and the state level pollution control board need to be should have a nodal agency and public participation. That is what main important to adapt to worldly transportation and to have vehicles. And CPCB ensures the monitoring and regulation, and they should have a green buffer zones around the cities. That places there should not be any particulate matter emission. Okay. So that will come with the mitigation measures should be good only with the combination of effective implemented scientific policies and technological inventions. And citizens need to be encouraged to participate in this type of schemes. Only government can't play any role. Yeah. So finally, the challenges and the way forward. How can we move on? So air pollution is one of the key challenges, as we all know. Fourth in premature death and fifth in mortality after dietary, high blood pressure, tobacco, and high fasting plasma glucose. That is a sugar, and we are coming up with the air pollution is the fifth region for total mortality. In 2007, you can see how much death, total number of death in terms of millions. So you can see here 5 million death in 2017 itself in a year, and continuous degradation of ambient air quality demand for effective measures, and the lack of infrastructural facility. That's what I'm saying. Resilient infrastructure to combat with this type of climate change. So civil engineers as a whole engineers, we have a role in this. And National Clean Air Program (NCAP) steps to curb air pollution. NCAP, it's all about India. I'm saying National Clean Air Program, again national level strategy for the reduction in the air pollution control at both regional and urban scale levels. You can see these are all the new policies like NOx standards was prescribed CNG and LPG, ethanol blending. There are cleaner fuels and leak flow fogging from BS4 to BS6 we have converted directly in 2020, and banning of biomass burning and the air quality index. These are all steps we have taken national level to reduce the air pollution. Yeah. So you can see NCAP was set up to monitor the reduction of 20 to 30%. Aim was targeted for PM 2.5 and 2.10 concentration in 2024. So you can see last year we have reached this 20 to 30% reduction as a national target. And yeah, but the limitations for NCAP is legally, it's not lack of legal binding targets, absence of complaint mechanism, data related issues. So we don't have a regional data and urban rural disappointment and inadequate financial capacity. So that need to be overcome. And ORF Observer Research Foundation that was on published in 2020. Following limitations are observed. These are all things you can see one by one. Absence of the legal mandates. So there is a delay in the implementation of NCAP action plan. So it was set up in 2020 means you have to start immediately. And absence of compliance mechanism, lack of accurate and independent and easily accessible data, data related implementation, lack of appropriate methodology to monitor the real time data. Urban rural disappointment, like you can see still relatively spare knowledge on the difference in the terms of air quality. So urban area, rural area, you can think about the difference in the air quality. So you can't adopt the same strategy in both the areas. So that need to be taken care. Only a small section of the country's population is closely being monitored for air pollution. So all the other rural areas need to be monitored, and one monitoring station for every 6.8 million people only we have, that need to be increased. And inadequate financial capacity, still lacking financial capability. So control of pollution, that earlier it was around, last year budget was 460 crore. Last year in the sense 2021 I am saying, and next year it was 470 crores. Only 10 crore increase. But it was projected we need at least 660 crores in that 2020 to 21 and 540 crores in 2021 to 2022, so that it could be easily converted. But they are allotting only spot 70 crores. That again, this 200 crores gap need to be addressed. That was the lack we are having. And NCAP trackers, they have, there is a separate portal for NCAP called NCAP tracker. Carbon copy and receiver living sciences have developed, and it trackers compliances and analyzes information on the air quality. So apart from government initiatives, some private sectors are also coming up with this clean air innovations. Like IKEA, they have turned rice straw into raw materials, and this, Siemens Mobility, they have come up with the traffic related air quality measurement in real time. So there is a small equipment that can measure all these pollutants. And again, we have a corporate social responsibility, CSI. All the industries are having corporate social responsibility. From that, they are actually, again, it's related to the carbon credits. And it was in India from 2014 onwards. And the companies with the net worth of INR 500 crores and the revenue 1000 crores need to spend at least 2% of their average profit to the society. In the last 3 years, average profit, like you have to take 2% and spend for the society development related activities like education, healthcare, and also to elevate the environmental sustainability. So that comes CSIR along with the environment. So most of the countries, like you can say companies, like you can see creating oxygen hubs. Cummins in Pune, they have also created this type of oxygen hubs by planting lots of trees, or you can create a forest. And MATS, let's say MIME, they have also taken part in tree plantation programs. And the transportation sector, what is the challenge? Like growth in the number of private vehicles, deterioration in the air quality, increasing greenhouse gas, and severe congestion that can be that need to be addressed. So, what are the mitigation strategies we can go with? So, declining sharing of public transport, future bus technology need to be electric buses. But the problem is the initial cost. Like 23 million was required for the hybrid bus, but 9 million is only required for diesel buses. So who will give this much money by the for the government? So that need to be taken care, right? So technology is fine, but who will give the cost? But if you are comparing with the air pollution's impact, this cost is very less. And non-motorized vehicle, as I mentioned, that need to be having a green mode of transport, we can say low carbon footprint, because no more carbon emission if you have a cycle or something. Minimal energy consumption, zero local emission, inexpensive compared to motorized transport. Because we don't want to put petrol every day to my bike, so it's inexpensive. And NMT has immense health benefits. If you are cycling daily, you'll get health benefits only. And unfortunately, NMTs are still neglected as a mobility option in favor of capital and infrastructure intensives. Oh, because we can't afford this much of cycles and all. I mean, afford in the sense, and also our infrastructure is not having this much sector. Like if you see Netherlands, they have a separate bus and bicycle lane in the road itself. And if you see Amsterdam, they have exclusive cycle lane in highways also. Like Auckland also in New Zealand, they have a separate cycle path at the highways. So that all need to be, India need to take care of this type of strategies, so that the people can transfer to non-motorized vehicles. So, yeah, in India also need to take care. Electrical vehicles, if you see, is one of the cleanest source of energy. Battery with less weight, more storage capacity. Nowadays, we are working on lots of semiconductors for most energy storage and durability, rapid exchange, recharge capacity, comparatively lesser cost. On-go charging also nowadays it came. So people are working on innovations, but implementation and behavioral change is very important. Yeah. So these are all policies mandated by the government, and alternate fuels. This is another important thing. So ethanol, if you say, it's considered as one of the most suitable alternate blending along with this whatever the fuel we are using along with the diesel and all. So B20 means 80% our diesel and 20% bioethanol. That are all B20, B40. Nowadays India is only with B20, but foreign countries and all, they are going with the B80. So that type of engines need to be developed. So expert committee and roadmap on ethanol blending in India by 2025, 20% ethanol blending. That's what E20 in the country. B20 is biodiesel, E is ethanol. So that's the roadmap, and they have a target and all. Promote technology for the production of ethanol and also in the engine based manufacturing. And bio CNG, you can say, glaring problem in the way of bio CNG, waste segregation at the source itself. If we give, they will produce CNG, right? So bio CNG is produced from all biomass, you can say, like algae or anything. We can use biodiesels. We can replace about 50% of our total diesel usage in the transportation sector. I also have a UG project on the biodiesel from the distillery waste or any wastewater, food waste you can take. And I have used the algae, a special algae called Empulcherima, that can accumulate, sorry, that's a yeast, that can accumulate 80% of its body weight by lipid. So lipid is, it can be extracted into ethanol. So that is a biodiesel. Okay, so I can make B20 along with this diesel, that can easily burn. So I can confirm that with this functional groups and all. Yeah. So that's another one is methanol economy. So Niti Aayog's methanol economy program is aimed to reducing India's oil import bill. So they have a low carbon hydrogen carrier fuel, and blending 50% of methanol in gasoline itself can bring down gas emission by 20%. See, 15% blending can reduce greenhouse gas emission by 20% itself. So think about 100% blending. So there is no emission of this type of greenhouse gases. And then 5 methanol power plants were designated in India, and 3 boat and 7 cargo vessels were using the methanol as a fuel, and successfully developed a 5 kilowatt methanol based reformer. These are all technologies happening in India. And innovation in transport sector, they have a world's first retrofit emission control devices, and 90% of the particulate matter emissions from the exhaust are the diesel. That's a capture, and that captured particulate matter can be used as a ink. So that is a new good technology, chalk shield. You can also Google it, and captures 90% of the particulate matter from a vehicle, that can be converted into pollution. Captured pollution is converted into ink. Yeah. And if you see inland waterways, so again, transportation sector itself, waterway transportation also emit lots of SOx, right? So that need to be again electrified. So India's first solar ferry electric boats was that's Aditya, and it's a catamaran ferry boat. And you can see it has a saving rupees savings of 11.5 million, and eliminating 165 thousand liters of diesel, and it has celebrating its first 5 years of success. So one boat you can say it's a ferry, but how to create, and what's the issue in creating all the e-boats? So that need to be addressed. That gap need to be addressed. In the crop residue, you can see lots of farmers are burning their crops, so that need to be addressed. And burning of IGP region causes severe air pollutions. And the shortage of time between the harvest and sowing for the next crop is the reason for burning. So farmers' perspective, easier to burn instead of sowing. So emitting a large number of hazardous pollution. For that, what we can do, crop diversification programs. So these are all programs you can see incorporating stubble into the soil. So instead of stubble burning, you can put the stubble inside the soil that can act as a fertilizer. And mechanized tools instead of hand sowing, you can also use mechanical or mechanical, not electrified. So mechanical seeders or super seeders you can use for straw incorporation. And composting you can do instead of burning, you can make it as a compost, or you can also burn it in the absence of oxygen. There's a process called pyrolysis. At high temperature, you can also produce a carbon rich biochar that can be used as a fertilizer, or you can use in the water treatment or any. Nowadays, cosmetics are also using carbon, activated carbons. Yeah. Then the financial aspect that can be taken care by the government by this type of linking with these programs like MG and RGA, and community agriculture in villages can help in providing community-based solutions. So industry sector, if you think what are the mitigation measures you can do, 28% global greenhouse gases from the industries and 90% carbon dioxide from the industry. So volatile organic compounds are emitting from the paints and all. So what's the way forward? Tri-component epoxy paints nowadays on water they are using, that is highly specific need for the metal industries, and truly minimal 1% VOC content. We can think about how much emission will be there, nothing. And fluid catalytic cracking, so that will convert the heavy metal product in the first distillation oil into high grade light products. This type of catalyst catalyzes surface contains sulfur, burning it into sulfur dioxide. So again, which emits together with the flue gas. Sulfur deposition can be eliminated. So the another one is BAT technology. This is patented technology can reduce sulfur dioxide emission by 85% by removing sulfur originating flue gas with a negligible amount of solid waste generation. Yeah. And then residential, how can we change? Again, we have a Ujjwala system, and due to faulty processing and drying, 80% of the rural households and almost 20% of the urban households are still using solid biomass for cooking. So we can change to this. Are all new innovations like radiant heat gas burners, and this wave cook food uniformly without burning like a microwave. Like radiants are nowadays coming, and not only LPG. Like radiants are having like last innovation program also. I had seen one of the professor from IIT Tirupati, they have developed radiant heaters for the mass cooking. They have implemented in Tirupati Devasthana Mega Kitchen also, and increasing the green cover by 45 crore trees. So that is again residential area. You can think about like one this technology you can see Agni Smukha claims that implementing platform we would decrease the carbon emission by 10 million tons per annum. How they are doing? See, this translates the increasing green cover by 45 crores trees, highest energy efficiency in renewable energy. And this scheme again implementing cleaner fuels, cleaner cooking fuel, that is LPG. Um, that's the second phase of LGB. They have Ujjwala 2.0. They have again sooner they are increasing the users for LPG. Like first 62%, they have increased it to 99.8%. Yeah. And the energy demands, we can go with this type of methanol or ethanol based or bio fuels, and has following commitments in COPs. Every year, our India participating in the um, yeah. So our country is also participating in this COP conference of parties, and they are having targets. So 30 to 35% reduction in 2030 is our India's commitment. So we have to reduce emission from the thermal power stations by new environmental norms and regarding suspended particulate matters. Yeah. So promoting renewable energies and develop solar parks in some of the reclaimed minimal areas like Tamil Nadu itself. You can see Neyveli Lignite Corporation, uh, uh, Kalunir in Tirunelveli district, and we have a largest solar power plants and wind power plants in Tamil Nadu, and Maharashtra. You can see 60 kilowatt power installed on the rooftops, that is the solar, and Telangana you can see solar power plant at Managuru, that is a 30 megawatt plant, and rooftop solar installation in Jharkhand. So these are all renewable energy you can see to tackle the energy demands. So these are all new strategies. Like Mexico, they have a paint on the mural that this paint can absorb the carbon dioxide in the atmosphere. Think about the innovation they have happened. So they are doing painting along with the anti-pollution graffiti. So that can absorb, break down the NO2 into purified form, contains no VOC, prohibit mold growth, and paint lasts for 10 years. So think about the technology. And London City, they have a biosolar leaf. So think about the why it's called biosolar leaf, because these are the panels, that panels have tiny plant that wash off carbon dioxide and releases oxygen. How the plants are working? It will absorb a carbon dioxide and it will emit oxygen, right? Same, this leaves, they are saying as leaf, but because it's a panel having tiny plant that is equivalent to 100 trees from the surface area of single tree. So for a single tree, how much area we need? In that, if you see this type of bio solar leaf, that can act equivalent to 100 trees. So think about the innovation. And city tree in Germany, so you can see this type of things you have already seen in YouTube and all. So living walls, they have a micro plant that could absorb the particulate matter and nitrogen oxides. And United Nations, they have a smog reducing granules, that is 3M has designed smog reducing granules. So photovoltaic coating that could like activated by the sun's UV radiation generating radicals, because radicals can overst radicals or whatever the radicals that can oxidize the particulate matter and any volatile organic compounds in the atmosphere. So all these are innovative solutions, so needs a collaboration between the R&D and implementation. That's what need of the hour. So finally, we are going with the sampling and analysis. So for in this week, we are only thinking of talking about the sampling and analysis of PM10. So what is PM10? The particle which is having the size less than 10 micrometer are called particulate matter 10, and 2.5 is called PM 2.5. So particle size should be less than 2.5. Why we are thinking about only 10 and 2.5? You can see here the coarser particles are 10 micrometer, finer particles are in 2.5 micrometer, ultra fine are from 1 to 0.0001, that is in nano size. So that are all ultra fine particles. So what is particulate matter? It's a mixture of solid particles and the liquid droplets suspended in the air. Okay, so think about the size. This is a human hair, one hair. So particulate matter 10 and particulate matter 2.5 that can easily enter into this size. These are all classification. Dust will be from 1 to 200 micro, smoke, fumes, chemical fumes, aerosols are indoor air particles like less than 1 micrometer. So what it will do? It can easily enter into the lungs. Even our alveoli are 0.45 to 0.56, that can our PM 2.5 can easily enter into this type of alveoli and they can affect the lungs. Okay, so how to measure this? There is a guideline for the measurement of ambient air pollution. So PM10 measurement guidelines was given. So this is the NOx standards. So as I mentioned, every pollutant have different time weighted average. Some pollutant may be 8 hours and 1 hour. So PM have annual and 24 hours. Major pollutant will be annual and 24 hour. This is a uh, like measurement period. And concentration limit standards for industry. Earlier it was industry, residential, and sensitive areas. Now only industry, residential, like rural are clubbed, and ecological sensitive area (ESA) was separated. Okay, for the PM10 level is 60 is the maximum, and for 24 hours you can make 100 as a maximum. If you are measuring PM in your home, not only home, outside, that's the indoor air quality. So outside, if you are measuring the PM10 for 24 hours, it should not be more than 100. If you are measuring 365 days, it should not be more than 60 average, I'm saying. So how to measure? There is a you have to use a gravimetric method. You have to weight how much particle collected. That's the simple principle. We have a sampler called a high volume sampler. So there is a video is there. So I'm just telling how it works. So this particulate matter sampler is called a high volume sampler for PM10. So air will go through this. Okay, this pipe like this. So air will go through this, and there is a cyclone here. Cyclone, what it will do? We have seen in the control devices, right? Particle will move, and PM10. PM10 means particle which is less than 10 micrometer, right? So above 10 micrometer, all particle will settle due to gravity. Below 10 will go into the box, and there is a filter paper. So all the particle will settle in the filter paper, and the air will go out. So this again filtration mechanism only we are using. But we have a cyclone to reduce the particle greater than 10 micrometer, that will be collected in a cup, and the remaining particle will go through the filter paper. Okay, so we have a glass fiber filter paper. It's like a A4 sheet of 20 cross 25 centimeter, and that need to be kept here. So the air will come out through this, and it will move in the cyclone, and all the 10 micrometer above 10 micrometer will be kept in the settled in the bottle, and less than 10 will go through this, and it will be filtered in the filter paper, settled in the filter paper, and the other gas will come out. Okay, the flow rate will be measured in this, because how to mention the unit for particulate matter? Microgram or milligram per meter cube of air. So I can measure the tissue paper before and after collection. I can say how much microgram or milligram of particulate matter collected. How to say meter cube of air? So we know the time. I can say 2 hours or 3 hours. I know the flow rate. This much meter cube per hour. So I can multiply and get how much meter cube of air collected. You got it? So meter cube of per hour is the flow rate. From this bubble, I can get water level into how much time, 2 hours I have collected. So I can multiply and I can get how much meter cube of air collected. If I divide it by the amount of particulate matter collected, then I can get the concentration of particulate matter. You got it? That's the sampling procedure. So here you can say before and after, after and before the filter paper weight, that some difference will give you the particulate matter concentration by volume of sample collected. Again, we have to control the quality and record of time sampling and total time and sampling and average flow rate are important. So you can go through the video, it's in the YouTube. And I think that this is one of the important things. The airflow need to be maintained at 1.1 meter cube per minute into 30 minutes if I am taking, or 60 minutes or 1 hour I am taking, that can be multiplied. Okay, this is the maximum airflow rate limited air. So hope you have learned more about today the conventions and air quality mitigation, air pollution mitigation strategies. I mean advanced strategies, and also finally with the particulate matter sampling procedure. So can I go with this older assignment now? So if you have any doubt, please post in the chat box. Okay, so we have give exam on computer from home, or we have to go to the exam center. Will be there. Exam center you have to go. Hall ticket will be released soon, I guess. It's related with the NPTEL team. I am not part of any NPTEL. I am just taking the problem solving session. So question paper setting. I am also giving exam. I have also applied. So I am not related with the professor. So I am just part of this problem solving session. So system will be computer based exam, and you have to go to the center and you have to write like gate exam. Okay. Yeah. So, any other questions, please post to the chat box. I'll move with this problem solving. Yeah. So, I will read the question. Please post the answers in the chat box. First question is, which of the following global agreement aim to protect the Earth's ozone layer by phasing out the ozone layer depleting substances? So, which protocol is majorly for ozone layer depleting substances phase out? So, that was after Vienna Convention. There was one protocol which paved the way for Geneva. Okay, Vienna will be for Montreal. Yeah, correct. Ozone layer depleting substances is in Montreal Protocol. It's not Geneva Protocol. Sorry. So what Geneva Protocol is for? I will go to the lecture material again. Uh, Geneva Protocol is for volatile organic compounds, not for ozone layer depleting substances. So full ozone layer depleting substances was given in Montreal Protocol. You can see here. Protocol was amended in 6 times. The most recent amendment to phase out the ozone depleting substances. One is hydrofluorocarbon. This will be confusing only, ma'am. So you can just I will give you a write-up, one page with all the amendments or protocol. All the protocols or agreement with what are the target pollutant they have concentrated. That I will post today itself. Okay, in the Google Drive you can see one slide. That will be easy for you to recall, or you can write in a paper. That will be very easy and useful. Otherwise, all this protocol will be confusing. Yeah. Second one, which of the following agreement aim to improve nation's ability to deal with the effect of climate change? So, which protocol was majorly with the climate change and align financial flows with low greenhouse gas emissions? So, which has aligned financial flows for the greenhouse gas emission? Here, Paris Agreement, because Paris Agreement they only reduce the global greenhouse gases so that we can reduce the global warming, and their aim is to limit the global warming to well below 2 degrees Celsius. So you all know, right? That's the Paris Agreement 2016. So this was spoken worldwide related to global warming. So global warming is related to emission of greenhouse gases. So greenhouse gases is related to Paris Agreement. Yeah. So here also you can say ability to deal with the effect of climate change and align financial flows with low greenhouse gas emission. All the states has participated in that, signed and ratified. Yeah. So the third question, please post the answer in the chat box. As per the given case study, so we have some case studies, right, for the impact of lockdown on the air quality. Which of the following pollutant increased after imposing the lockdown? So not only in Brazil, most of the case studies we had seen, one pollutant is getting increased, others are getting drastically decreased. So which pollution is getting increased? Why? What is the answer? So first, all other carbon dioxide, carbon monoxide, NOx, and all got getting decreased. Only ozone is getting slightly increased due to the absence of NO. Because what NO will do, ozone plus NO will give you O2. So that's not happening because of lesser traffic emission. So if NO is there along with VOC, ozone will be formed. Ground level ozone will be formed. That is one of the problem. And this destruction is happening in the stratosphere. The same is not happening in the troposphere or ground level. So ozone level is getting increased during the lockdown period. Hope you understood this one. So ozone is the answer. Which pollution is getting increased? Ozone. Here you can see Brazil. Uh, all the pollution is getting reduced by 70%, 60%, but only ozone is increased by 30% due to the less emission of or no emission of NO. Okay. Fourth question. Which of the following mitigation strategy is not focused to reduce the emissions from transportation sector? So we have some mitigation strategies, right? 14 mitigation strategies, I guess, we have seen for transportation sector. So on that, which is not for transportation here? Congestion pricing, non-motorized transportation, Pradhan Mantri Ujjwala Yojana, auto fuel policy, so which is not related to transportation sector. So one is cleaner fuel for Ujjwala Yojana is cleaner fuel, but not for transportation. It's for cooking. So this is not related to transportation. Yeah, you can see here. Congestion odd scheme system is related to transportation. Non-motorized vehicle is related to transportation mitigation strategies, and auto fuel policy, as I mentioned, BS4 to 6 and all engine manufacturing and all related to transportation. But Ujjwala is related to residential and commercial sector for the safeguard and health of women and children for cleaner cooking fuel. Yes. Coming to the fifth question, match the list. So this is related to again transportation only. Transportation, we have three golden principle. One is avoid, shift, improve. So what is avoid? What is improve? Sorry, first what is avoid? The Q. Reduce travel demand. So Q2 is correct. Yeah, is correct. Which to shift? Private to public. So private motorized vehicle to be shifted to public or non-motorized vehicle. What to improve? Enhance the fuel quality. Okay. So P3, Q2, R1. This is correct. This is the golden principle of transportation emission mitigation. Right? Avoid, shift, and improve. Avoid the travel demand or reduce, shift from public, private to public transportation or non-motorized vehicles, improve the quality of fuels or technology and strengthen the system for air pollution control. Yeah. So which is incorrect related to non-motorized transportation mode for traveling? Non-motorized vehicles, what are the benefits? Low carbon footprint, minimal energy consumption, zero local emission because there is no emission if there is no fuel. Expensive compared to motorized transport. It's inexpensive because uh, non-motorized vehicle, I don't need to put any petrol or diesel. So it's inexpensive. So this option is wrong. They are asking which is incorrect. So related to NMT, non-motorized vehicle, expensive compared to motorized transport is wrong. You can see here the green modes of transport, lower carbon footprint, minimal energy consumption, zero local emission, inexpensive compared to the motorized transportation, and also have health benefits. Okay, so option D is correct for the last question. Okay, can we move to seventh question? Yeah. Biochar is a finely divided carbon-rich porous substance that obtained from the crop stubble through the process of. So for the farmers, farming or agricultural sector, people are burning the stubbles, right? So instead of burning, we have given a solution so that at high temperature in the absence of oxygen, we can burn the biochar, burn the stubbles to produce biochar as a carbon-rich material that can be used as adsorbent. What's the process called? Composting, pyrolysis, mechanical processing, and happy seed. It's called pyrolysis. Pyrolysis is the method that will produce activated carbon or biochar. Okay, yeah, pyrolysis is correct. You can see here biochar. Composting will give you fertile compost, and biochar will give you production of the pyrolysis is the process which will give you the biochar from the crop staple. Stubble is the waste residues. I mean agricultural residues. Okay. Related to PM10 measurement, the glass fiber filter paper used in the high volume sampler. High volume sampler is for PM10 sampling. For the sampling of PM10 need to be conditioned for. As I mentioned, the filter paper is there now that need to be conditioned. I mean that need to be kept in desiccator for at least 24 hours so that there is not be any moisture, because measurement of PM is in microgram level. So whatever the particulate matter before and after filtering, the filter paper need to be kept in desiccator for 24 hours before taking measurement of, I mean measurement in the sense weight measurement. Okay, so filter paper need to be kept in desiccator for 24 hours. After that you have to take the initial weight, and after filtering all the particulate matter you have to again keep it in the desiccator to absorb all the moisture. I don't want any moisture weight, I want only the particulate matter weight, so moisture need to be desiccated. So the conditioning is for 24 hours. Okay, so you can see condition the filter paper in conditioning room or desiccator for 24 hours. So after reading also you have to do the same. Yeah. So again, it's related to standard for PM10. What is the annual ambient air quality standard for PM10? So pollutant is PM10. Okay. So which period? They are asking two periods, right? Annual or the daily. So annual. We have annual and we also have 24 hours, right? They are asking annual. Okay. So we have another two categories. One is residential, rural, or industrial area. Another one is sensitive areas. Okay, they are asking about residential. Okay, annual residential, what is the value? So for 24 hours you can say 100. For annual you can say 60. So this is the standard for PM10, right? So 60 is the answer, not 40. 60, ma'am. You can also go through the value here. See, annual is 60, 24 hours is 100. That is daily for industrial and ecological. Okay, 60 is correct. I already posted the whole value. You can see for all the pollutants. So this is only for the particulate matter. 60, 100. It's not 40. So last question. In sampling of PM10 using high volume sampler, what is the cut point diameter of the inlet particle collected by the filter paper? Cut point dia is what is the particle that is entering into the filter paper. So I am just entering all the air into the equipment, and that will be going through the cyclone separator, and that cyclone separator will settle all the particle greater than 10 micrometer. Because it's PM10, I need only the particle less than 10 micrometer. So all the particle greater than 10 micrometer will be settled here. Only the particle which is entering into the filter paper will be less than 10 micrometer. Okay, so that's the cut point dia. Which point I am cutting? That's the cut point dia, that is 10 micrometer. Okay, answer is 10. Here you can see. So less than 10, greater than 10 are all coming inside, or greater than 10 is coming out, and filter paper it will be only less than 10. So cut point diameter less than cut point 10 microcube of inlet are collected by the filter paper. Okay, you got it? If any more doubt, please post it in the chat box. I'll be here in the meeting for another 5 minutes. Thank you for joining today. We will meet next week 6 to 8 on Tuesday. That will be week 12, last week regular session. And I also scheduled one more additional problem solving session to discuss all our 2025 assignments. This is 12-week assignments. Okay, so that is on Wednesday next week. Wednesday is 16th of April. So kindly join 15th of April 6 to 8 Tuesday. Again 6 to 8 on Wednesday for extra session. Thanks for joining. Don't forget to give the assignments on time. Tomorrow is the deadline for 11th week. Please go up with this deadlines. Top best of 8 assignments will be taken for mark consideration. You have to score the minimum score. Okay. If you miss any assignment also, don't worry. Out of 12, you can miss 4. and you can miss any number of assignments, but the minimum mark should be gained. Yeah, yeah. Thank you. You can leave the meet if you don't have any doubt. Thank you for joining. Yeah. Thank you for joining. You can leave the meet now. If you don't have any questions later, also you can post it in the uh, Google Forms. I mean, the Google Groups. I will answer periodically there also. Today I will address all the questions there. Okay, thank you. I'll end the meet if you don't have any more questions. Thank you.